In this problem, I'll talk about the motion of a car in a horizontal circle on a dry day and on a rainy day. So a car is moving in a horizontal circle. The radius of the circle is given, which is 450 meter, and the coefficient of static friction between the car tires and the ground is zero point 0.7 on dry day. And on a rainy day, the coefficient of static friction is 0.2. And we have to find out what is the maximum speed with which the car can move into this horizontal circle without being pushed away or without sliding away. Okay, so let's say this is a car and this car is moving into the horizontal circle. Any object can move in a horizontal circle when there is a force that is acting towards the center of the circle. There must be a force. That force is there must be a force to provide the necessary centripetal force. Otherwise, the particle cannot move into the circle. There must be some sort of force. When a car is moving into a horizontal circle, the friction force provides the necessary centripetal force. Okay. So without, if it is a, let's say, if it is a frictionless surface, there is no friction at all, then the car cannot move into the circle at all. When you try to move into the circle, it will skid away because there is no any friction. So in this particular example, if you see here, the car is moving to the circle. So the only way it can move is the friction between the tire and the ground, that is called the frictional force, is acting towards the center of or acting towards the center of the circle. Okay, it is radially inward, and this force provides the necessary centripetal force. So let's now find it out. What is the maximum speed at which this car can move into the circle without being skidded away? So here the coefficient of static friction on a dry day is 0.6. S stands for the static friction and D stands for the dry. The radius of the circle is 450 meter. And again, the mu SR, S stands for the static and R stands for the rainy day, which is 0.2. And as I mentioned, the friction force provides the necessary centripetal force. This is the frictional force. And how do we find out the friction force? So the friction force is given, we know that the friction force is mu times the N, and N is the normal force. So we need to find out first the normal force. So this is the free body diagram. The weight of the car is always downward. That's the weight. And the normal force is perpendicular to the surface, this N. And the frictional force is towards the circle or towards the center of the circle. So if a particle or if the car is moving into a circle, then the centripetal force, this frictional force provides the necessary centripetal force. That's exactly the equation I have written down here. This centripetal force, mv square over r, is the centripetal force. And this centripetal force is provided by the frictional force. mvd, vd stands for the velocity or the speed on a dry day. And this frictional force can be given by mu sd times mg. as I mentioned here, the frictional force is given by mu times n, and in this case mu n is equal to mg. So this is the formula for calculating the frictional force. Okay, this mass and this mass cancels out. Now we can solve for the velocity or the speed, and the speed vd is given by mu s gr. It doesn't depend on the mass, so it doesn't matter whether you are carrying a heavier mass or you are driving lighter mass. It doesn't depend upon yes, of course the centripetal of the frictional force depends upon the mass, but at the same time the velocity does not depend upon the mass here. So the velocity now can be calculated because all the values are given. Mu sd, which is the coefficient of static friction, is 0.6. The acceleration due to gravity is 9.8. The radius is 450. If you plug in, what you get is 51.4 meter per second. And if you change it to kilometer per hour, you'll get 185 kilometer per hour on a dry day. And if you do the same calculation on a rainy day, the only thing that is changing is the mu sd. In this case now you have to use mu sr, which is the coefficient of static friction on a rainy day, which is 0.2 now. If you solve it again, you'll get 107 kilometer per hour. So on a rainy day, you are significantly reducing the speed because there is not enough friction to provide to negotiate the turn or to make the car move in horizontal circle. That's the reason when it is snowing or when it is raining and on a turn, we significantly reduce the speed to negotiate the turn. And what I would like you to point it out again, just think about this equation here, okay, and make sure that you understand this equation. This is again the required centripetal force which is provided by the frictional force. Without the friction, we cannot drive a car into a circle. There must be some sort of force providing the necessary centripetal force, and in this case it is the frictional force that provides the necessary centripetal force. So this is it for the car moving on a horizontal circle on a dry day and on a rainy day. Again, if you have any question, write down your question in the comment section below, and do not forget to like, share and subscribe the channel. Thank you.